Hi guys, now today we are going to learn about Black-Scholes-Merton model. This model is important because the other model that we were talking about, we know the binomial tree model, which is a pretty simple method, but it cannot be used for complex calculations of option pricing, option value. So since it can only calculate about up to 2 years, we can calculate up to 3 or 4 years, because it becomes, if we do that, it becomes very tedious. So considering that Black-Scholes and Merton has developed a model using some formulas, we will be able to find out the value of options. So we'll be seeing how to develop what are the formulas and how we'll solve those problems using Black-Scholes-Merton model. Come to stock prices and return distribution. So this is what the basics of Black-Scholes and Merton model. There's too many assumptions that has been made by Black-Scholes and Merton. So one of the major assumption is stock prices are logarithmically distributed or continuously distributed. So this is a formula given by them to calculate mean and standard deviation of a particular stock. So this goes by ln of st is approximately equal to n into ln S0 plus mu minus sigma square by 2 t, comma means this is the mean part, standard deviation part is sigma into root t. So this is how we calculate in logarithmical distribution the mean and standard deviation. St is stock price at time t, S0 is stock price at time 0, mu is expected return, and sigma is volatility of stock per year, t is time period. So if you solve an example, you'll be able to understand how this works out. We'll take an example. Assume a stock has initial price as 0.25, expected return 12 per annum 12%, annual volatility 20%, calculating mean and standard deviation of a stock in 3 months. Coming to the answer of this question, just substitute everything given in the question. N into ln of 25 plus ln of 25 plus 0.12 minus 0.2 square divided by 2, which is the volatility, into 0.25, which is time period 3 months, 0.2 into root of 0.25 time into volatility. So it is pretty straightforward calculation for volatility, which gives 0.2 into root of 0.25, which gives us 0.10, which is standard deviation straight. But for the mean value, we'll have to find out, we'll have to calculate ln of 25. Ln of 25 can be calculated using our calculator, which is most of the scientific calculator, or we can use the table also. So calculating this, we'll get 3.244, which is a mean, and by this means that the mean of our distribution is 3.244 and standard deviation is 0.10. So considering for 95% of the times, 95% of total distribution, this being a standard deviation curve will be between the 1.96 and 1.96, which is a amount equal to minus 1.56. This is minus 1.96 and 1.96, this being the normal distribution. We'll have to calculate under what this ST value, stock at the time t value, will be in between for a particular period. So for that, we'll have a formula. This is our mean, which is we have already calculated, minus 95%, whatever is there in the 95%, into 0.1. That is our standard deviation. This is e raised to 3.24 plus minus 1.96, which is this part, and here 3.244 plus 1.96, which is this part. So if you take plus or minus the 95% corresponding value in normal standard distribution table, will be getting 21.073 less than ST less than 31.187, which just means that the stock price will be in between 21.073 and 31.187. So what is the meaning of this and how it works is, so dividing the mean and standard deviation by t, the result is continuously compounded annual return of stock price, Specifically, the continuously compounded annual return are normally distributed with a SD and mean of. While doing this exercise, we have found out that dividing the mean and standard deviation by t result in continuously compounded annual return of stock price. So that will give you the continuously compounded annual return of a stock price, and the mean and for continuous distribution continuously compounded annual return will have to divide it by t, and the mean and standard deviation will be mu minus sigma square divided by 2 and sigma divided by root 2. That is only sigma into root t by t, which gives sigma by root t. So this is how we calculate mean and standard deviation of a continuously compounded return. This is logarithmic formula, this is continuous formula, that is the difference. So this is how we end up in a conclusion using stock returns and distributions. An example of the previous formula. In this question, assume stock's expected return is 12%, annual volatility is 20%. Calculate mean and SD of probability distribution continuously compounded. Average rate of return over 4 period. This is continuously compounded return. The last formula should be used. That is 0.12, that is expected annual return mu, minus 0.2 square is volatility by 2, which gives 0.10, and standard deviation is 0.2 divided by root of 4, which is 2, which gives 0.10. So mean and standard deviation is found out using the previously arrived formula. That is because logarithmic distribution divided by t will give you continuously compounded formula. So that's all. Finding out expected value using a log-normal distribution, properties of log-normal distribution. So there is a formula e raised to st. The expected value of stock at time t is equal to s0, that is stock value now into e raised to mu t. Mu means expected return, t means at the time period t. So length of the time period. So this is just a normal compounding formula, which is being normal continuously compounded formula that is being used here. We'll take an example. Stock is 25, expected is 20%, calculated explain. This is future value is equal to present value into e raised to rt kind of formula. So which gives 25 into e raised to 0.2 into 0.5, which is the time period. Time period is 6 months, so which gives 27.63. Pretty simple formula. So consider a portfolio that has the following return: 5% for 0.4%, 9%. Calculate the annualized realized annual return realized by this portfolio. So assuming that these returns are given in quarter, but this has not been given in the question, but solving they have solved it like that. So it will be given 1.05, which means 1 plus 5%, 1 plus 4 minus 4%, 1 plus 9%, 1 plus 6%, 4 raised to 1 raised to 4, which is this raised to 1 by 4, this raised to total minus 1, which will give us, for giving us the percentage early, this minus 1 is being done. The total realized profit is 3.9%. Estimating historical volatility. This is another easy topic. While finding out the volatility for, if you know volatility for say a week, which is 5%, then we'll just root it by the time period to find out what is for maybe 52 weeks, that is 1 year. So for a week it is 5%, and for 1 year it will be root of 52 weeks into 5%. It will give us approximately 52. One minute. Let me use the calculator. 52 root into 5. It will give us 36.06% will be the annualized volatility. So simply estimated volatility multiplied by square root of number of trading days in a year. So common thumb rule is, okay, while using this we should not use like this. They are saying we'll be using last year's, if we want the length of the period like 1 week, we have to take last year's and we have to project. If we need 1 year's, when while projecting we'll have to take last year's whole. So whole of last year. We should not use this formula, that's what they are saying. So on the ex-dividend date, stock price will naturally decline because stock price will be the lowest because dividend has already been paid. So when using historical data to calculate volatility, best approach is to remove stock price on ex-dividend date from the data set. So Coming to the most important Black-Scholes-Merton model. So if you see, to derive the Black-Scholes-Merton model, riskless portfolio is considered. The same portfolio is being considered for our finding out binomial tree model also. Many places this riskless portfolio model will be considered. Why? Because a riskless portfolio is sure to give risk-free rate of return. So the rate of return will automatically get from there. So finding out something with that becomes very easy. So there are certain assumptions that has been taken by our BSM model, which I'll list here. Price of underlying asset follows log normal distribution that I've already told you. The continuous risk-free rate is constant, known and always available for borrowing and lending, which is an assumption which has been taken, which is not very true. As you know, borrowing and lending rate risk-free can only be done by major banks, etc. Cannot be done by everyone. So trading is continuous. Trading may or may not be continuous, but trading is assumed to be continuous by BSM. Volatility of underlying asset is constant and not, which is not true, but assumed by BSM model. Option values depends on volatility of price of the underlying asset or interest rate. That is true. That is true. Yeah, right. Markets are frictionless. There are no taxes, transaction cost, restrictions, short sales, and use of short sale proceeds, which is a very big assumption taken by BSM. And the underlying asset has no cash flow, such as dividend and coupon payment. This is also an assumption, weird assumption. The option valued are European options, which can only be exercised at maturity. The model does not correctly price American option, so you can value European option having all these assumptions. Still, the Black-Scholes-Merton model is only model that values options properly, so we are using it even now. So binomial tree model can value up to a definite time period, maybe 1 or 2 time periods. After that, we will have to use Black-Scholes model, even if there are many weird assumptions taken by BSM model. So coming to the real Black-Scholes-Merton formulas. So there are two formulas which is given by Black-Scholes-Merton. The derivation of it, which is very difficult, so and very lengthy. So anybody doing this valuation should be doing with this formula by hearted. We cannot write down the derivation in one page, so we'll go by this formula as of now. First you'll have to by heart this formulas of call, finding out the call value. This is a formula for finding out put value. So with this you'll be able to, if you remember this formula, you'll be able to find out the value of call and put. But for finding out the value of call, after finding out the value of call, you don't have to use the put formula. You directly use put call parity. I'll explain to you what it is. So by using Black-Scholes formula, call value is equal to S0 into ND1 minus X, that is a strike price, into e raised to minus RT. R is continuously compounded risk-free rate into 2, T is time to maturity, and ND2, which is cumulative normal probability of that event happening, and ND1, cumulative normal probability for this happening. So D1 and D2 is nothing but ln into S0, that is stock price, divided by strike price, plus risk-free rate, plus 0.5 into sigma square, into, that is sigma square by 2 into t time period, divided by sigma into root t. So D2 is equal to D1 minus sigma into root t. So this is how we find out this, and with that ND1 will be finding out using our table. So this is a outline of these formulas and Black-Scholes-Merton formulas. With the while finding out the C0, we'll be finding out P0 with using our put call priority theory, which is nothing but value of call is equal to value of call plus our strike price into e raised to minus continuously compounded rate into t is equal to P0 into stock price at 0. So using that formula, we'll be rearranging it and finding out put value also if you get the call value. But while explaining this, you may not understand this. You'll have to go to the problem. So we'll take up a problem. Coming to the problem, Suppose the value of Vola Incorporated is trading at 50, strike price exercise price 45. In 3 months, continuously compounded risk-free rate is 5%, standard deviation is 12%. BSM model, calculate the value of call option. So for calculating the value of call option, first we'll have to calculate D1 and D2. From D1 and D2, it's a simple calculation to value our call and put option. So we'll be finding out call option since only call option has been asked. If put option is being asked, use the simple formula of put call parity. So it is like D1 is equal to ln into stock price divided by strike price, which is 50 by 45 plus 0.05, which is the risk-free rate, plus 0.5, which is the formula, into 0.12, that is our annualized standard deviation, square into 0.25, that is a time period of 3 months, divided by 0.12 is again the standard deviation into root of 0.25, that is 1/4 of an year. So which gives us 1.99. So from D2 is only 1.99 minus the denominator of this. Always keep in mind while calculating this, you don't have to calculate the denominator again. The denominator, this value again, we'll have to just use this value here also and subtract it to get 1.93. So from partial cumulative normal distribution table, we'll be getting 1.93. There is a table known as that you might be very familiar with. If you are not, also no worries. Most of the question asked, they'll be giving it. Nobody will ask you to go to normal table and find it out. So this will be given. So 1.93 is corresponds to 0.9732 and 1.99 corresponds to 0.9767. So ND2 is equal to 0.9732 and D1 is equal to 0.9767. So finding out this is ND1 and this is ND2. So finding out call option is equal to our stock price is into ND1 minus strike price into e raised to 0.05 into 0.0525 into ND2. So putting that formula, we'll get 48.84 minus 43.25, which is 5.59. Which is simple. Putting a formula will give you the value of call option. It is just that we'll have to remember all this formula by heart. There is a way, ln into s minus x, which says that what is the confusion that arises here, what is on the top, x or s. Whatever comes first in the alphabetical order, that is s, will be on the top, divided by x. So into r, then comes r plus 0.5 into standard deviation, that is sigma square, into time period. Sigma and time period will come together. Everywhere it will be coming together. So whenever you are doing sigma square or sigma, it will be together only. So this is sigma 12 square and 0.25. Here 0.12 into root of 0.25. So this is how the formula works. Very simple formula. If you get the formula, you will be easily calculating whatever the requirement of the question is. So this is how Black-Scholes model actually works. It is a pretty simple calculation with, if you remember the formulas correctly, which is very easy, very simple formula. It might seem a little odd when you are seeing it the first time, but if you work out 2-3 problems like this, you'll be able to crack it in 2-3 problems time. We will be seeing what is the implication of dividends, warrants, and implied volatility in BSM model of call pricing, call valuation. So first we'll be seeing dividends, then we'll go to warrants and implied volatility. For dividends, let me take the pointer. Since the BSM model is continuous time, the practice of S0 into e raised to qt substituted for S0 in BSM formula. This means we will be computing the value of stock at having a continuous dividend yield of q raised to t, rather than computing something for like S0, that is stock price at now, since it is paying dividend. That is only difference here. We'll do a problem and you'll understand. Vola Incorporated, it pays dividend yield at 2%, trading at 50, exercise price 45, 3 months period, 12% annualized return, risk-free rate 5%. Using BSM, calculate the value of call option. So substituting d1 and d2 in formula, d1 into s divided by x, 29.75. This is r again. R comes next, 0.05. Then 0.5 is in the formula into 0.1 to the square, that is sigma annualized volatility square, with sigma every time will come 0.25, that is 3 months. Again divided by sigma 0.12, time will come with it, root of 0.25, which gives 1.91, and d2 again substituting this will get 1.85. If you see the partial cumulative distribution table, ND1 also is corresponding to 1.91 will be 9719, and corresponding to 1.85 will be ND2, which is 0.9678. ND2. Okay, so that's it, and we'll be valuing call after that. CO is equal to 49.75, which is calculated over here, then into 9719, 45 into e raised to 0 0.05 into 0.25 into 0.9678, which gives the answer at 5.34. so you should note here that the value for calculating the call value at in Black-Scholes model without this dividend yield was 5.59. so the dividend yield has actually decreased our uh, call value by about 0.25 or so. So that's because of the coming of this difference. This 0.25 here has been decreased due to the yield of our security, dividend yield of our security that is being paid to us. So that's how dividend impacts Black-Scholes model. Coming to pricing, using pricing options using dividend paying stock. So we'll explain this using an example. So it is said that, as we all know that this value of a call option decreases when a dividend paying stock comes into picture. Without dividends, the value of a call will be much higher than with the uh, dividend. So we'll be seeing that here how it changes. So that is pricing options. We'll be first given with an option without option value without dividend, then we'll be adding dividend to that and getting into another option value. So I'll be doing that with an illustration, so please listen. Assume we have non-dividend paying stock, 100 rupees, current price 100 rupees, volatility 20%, RF 7%, 6 months call option will give us 7.43, value of 6 months call option is 7.43, put option is 3.9. Now assume stock is paying 1% dividend in 2 months and $1 dividend in 2 months and $1 dividend in 5 months. Compute value of a call option on dividend paying stock. So first it is being given that without paying a dividend it will be giving us 7.43, and put option will be giving 3.99, which is pretty irrelevant here. So call option will be giving 7.43. Compute the call option with dividends. So dividend is $1 in 2 months and $1 in 5 months. So we'll have to find out the procedure that we will be going through is like first find out the present value of dividends, then reduce it with our S0 place, that is 100. Assume x to be 100 because that is the price that we have as of now. So then we'll be finding out d1 and d2, then we'll be finding out call option value. So that is pretty simple process. Just thing we'll have to remember is we'll have to find out the present value of dividend 1 and dividend 2. Not we won't be subtracting it directly from our current price of 100. So PV of D1 is equal to 1 into e raised to 0.07 into 0.1667, that is 2 by 12. PV of dividend 2 is 1 into e raised to 0.07 into 0.4167, that is 5 by 12. This figures comes, and we'll be subtracting that with our 100, which will give 98.01. Then we'll be using the formula ln into s by x into our rate will come 0.07 plus our sigma will come 0.5 into 0.5 into 0.2 the whole square into, then after sigma the time will come, the whole bracket close, time is 6 months, 0.5 divided by 0.5 root into sigma will come nearby that, which is 0.12, 0.20. So substituting all the values, you'll get d is equal to 0.1783, d2 is equal to 0.03688. ND when from partial cumulative distribution table will be 0.5708 and ND2 is equal to 0.5747. So substituting this value, will be getting the value of call as 6.26, which is much lesser than 7.43 that is being calculated by us using our non-dividend paying stock model. So this is how we calculate the value of an option given non-dividend paying stock and dividends. This is just a backworking of our this might seem like a backworking of our Black-Scholes real model, but it seems first the only step which is more than the Black-Scholes model here is just finding out the PV present value of dividend 1 and 2 and subtracting it and finding out new S rather than the old S that we already have here. So this sums up how we will price an option given a non-dividend paying stock and dividends. So effective dividend in American options. So we'll be discussing that. As you know, if there is no payment of dividends, the American options and European options will have no difference in value of call option or any option. So if there is a dividend is added into the equation changes a little bit. How that is being done, we'll be discussing here. So as you know from Black-Scholes model, if the value of the option decreases as dividend is getting added, because it is a positive yield. So because of the positive yield, the value of call will decrease if dividend is added to the stock. Okay, since the stock value reduces. So coming to American options, let me explain. The unexercised value of call option, that is given by S0 minus X into e raised to RT minus RT. So what we are doing is just S0 is the strike price, stock price now, X is strike price. We are bringing it back to now by using risk-free rate and time, which will give us X into e raised to minus RT, and that will be the value of the call. So is always more valuable than the value at the exercise price. Okay, if you see e raised to minus RT will be a figure in decimal, so this will reduce, X will reduce accordingly, and S minus X will always be more than X into e raised to RT will be always be more than X0 into X. So that is a mathematical way to see it, but in reality it is like whenever the value of call in between will be more than the value of the call at the end, theoretically, and practically also it will be the same. So then we'll see mathematically what happens when a dividend gets paid in it. So in a dividend, the stock price when the dividend is not paid at time Tn is S into Tn minus X, and when we add the stock at the dividend, that is we are adding dividend, we are paying the dividend, then S into Tn minus dn, which is the dividend, minus X into e raised to R minus into T raised to Tn will come. So it is like we are reducing our stock value with the dividend, and the time is also getting a slight alteration due to the dividend being paid at that point of time. Okay, so what will happen is the end result is dn should be greater than X for exercising the option. For exercising the option, the stock value prior to the dividend should be more than the stock value after the dividend. Okay, if that is there, if I am getting more now than the next day, that is after the dividend payment, I'll be exercising today. So for that we need to equate the both equation, and we'll find dn is equal to X into 1 minus e raised to R into T minus Tn. So from this equation we can infer that closer the option of expiration, that is T raised to Tn, will be lesser. So closer to the expiration, larger will be the dividend, and the larger the dividend. So DYU is greater than all these things, which means dividend is much larger. So under these circumstances, if this is less, whole value will be lesser than dn. So in these two circumstances, it is optimal to early exercise. So what they are saying is, if the time period is very closer to option expiration or our dividend is much larger, then we'll have to exercise early. So that is how the effect of dividend in American options is worked out. To valuation of warrants. So first we'll explain what is warrants. Warrants are attachments to bond. It gives the holder of the bond right to purchase shares at a stated price. So it is a kind of a call option that gives a right to buy shares at a stated price. So after purchasing bonds, these bonds can be sold separately. That's why it is considered as an option. So this is primarily the background of a warrant. So thing is that we'll have to value this warrant. While valuing this warrant, how to value this warrant, that is the main consideration. The outstanding shares is affected by the exercise of warrant. This is another point, because whenever this warrant gets exercised, uh, the amount paid shares will be less than the pro rata market value. So the value of equity shares will fall with exercise. So since warrant is given at maybe 65 and the trading of the shares will be going on at 100, so it will be lesser than the market price. So when this comes, 65 rupees comes per warrant comes into their shares, their total number of shares, the total value of equity per share decreases. So we'll have to assume there is no benefit of company for issuing warrants. That is because if the benefit is there, that will automatically increase the their reserves and surplus, and the value of the company will increase. So assuming there is no benefit from the issue of warrant, that is a critical assumption here. It is being assumed that because somebody issues a warrant, they will get some money from the investors, and from that money they will make value and will add that value will add into their reserves and surplus. So total value of company's reserves and surplus plus the investor's equity divided by number of shares, means not the divided by number of shares, equity shares plus reserves and surplus. So if you want the value of the share, value of the company per share, you'll have to divide by number of shares. So this will get reduced if we assume that there is no benefit in reserves and surplus by the issue of warrant. The value of each warrant will be n, that is number of shares outstanding, divided by n plus m, that is shares after the issue of warrant, into value of regular call option. Since warrant can be considered as a call option but not actually a full-fledged call option, it has a particular characteristic of a call option, that it has a right to buy at a stated price. That's all. So that call option, the value of call option shall be reduced by uh, the number of shares outstanding divided by total shares after the issue of warrant. That ratio, it shall reduce the value of call option. Since call option will not give every advantage, warrant will not give every advantage of call option, this shall be reduced as such. So the rest part, m divided by n plus m, that is the number of warrants issued by total number of shares after the issue of warrants, will be into value of call option, will be the amount by which our share price reduces. So it is given that in valuation of warrants, it can be said that one part, that is n divided by n plus m, will reduce the value of the call, and value of the warrant will be given by that, and the other part, m divided by n plus n into value of regular call option, will give us uh, the reduction of equity share price per share for our company. So that is a reduction will give. If 50 is the price, if m divided by n plus m in value of regular call option is 2, then 48 will be the residual value after we issue the warrants. So that's how valuation of warrants is being done. Coming to volatility estimation, this is one important step in VSM model, by which the VSM model is used to find out the volatility. So implied volatility is a value of standard deviation of continually compounded rate of return that is implied by the market price of option. So what we need to do is first find out stock price, then you find out stock price at different dates, and you find out the returns, that is stock price today minus stock price yesterday divided by stock price yesterday will give you the rate of return. Make it continuously compounded by ln into 1 plus r, which is log formula. Just using log formula, make it continuously compounded. Then after continuously compounding, you find out the uh, using that rate of continuously compounded rate of return, you find out standard deviation r minus r0 by n type of formula you put, and find out the rate of degree of standard deviation and sigma square and sigma. And after that, with this you can find out the volatility. This is how you estimate. So what is the help of BSM model is that BSM model has 4 or 5 characteristics which is quite observable. That is stock price, exercise price, risk-free rate of return, time period, etc. So with that we can estimate the volatility quite clearly. So there are two other two other terms that we need to learn, that is volatility smile and volatility surface. Volatility smile is nothing but uh, volatility is that volatility varies with strike price such that graphically plotted implied volatility against strike prices produce a volatility smile. Okay, just the plotting of implied volatility against strike prices, that is just what is called a volatility smile. And this strike prices and implied volatility is being found out by the method I have told you just now. And assessing the volatility and surface involve looking at an implied volatility relative to strike price and time to maturity. So that's all about volatility estimation. This is just a process. First take a stock, take the prices of different dates, find out returns like P1 minus P0 divided by P0. So from that return, convert it into continuously compounded ln into 1 minus r0 or r1, whatever the rate of return is, and find out their standard deviation, and their by taking root of that standard deviation find out the volatility. This is basically a theory topic. So that's all in volatility estimation. Thank you. Hi guys, if you liked my video, like, share and subscribe. If you have any suggestion, please comment. Thank you.